I guess we found k was equal to 1, right? So yeah, let's just go for it, okay? So, did you take notes of this or something? Screenshot and all, bro? For real, bro? You took the notes and all those stuff? Because I'm gonna erase this. So we found k is equal to 1, okay? So, the most important thing we have found out is k is equal to 1, bro. Yeah. K is equal to 1. Now what you have to do is, PDF means not the PDF file, like file extension. PDF means probability distribution function. It is it's like short form. Like what do you say that abbreviation? I guess. So yeah, PDF x f of x equal to x k x square e raised to minus x. When x is greater than 0, find when you put x in it, so you just consider like x and f of x. Tell me, let me show you. So wait a second. F of x itself is the probability stuff, okay? Probability, but only x. Oh wait a second. Only small x. Whatever you put it, it is like random variable, okay? Random variable stuff, okay? That you have to keep in mind, okay? So that's how we make changes, like difference between discrete variable and this variable, okay? Let's just go for it, bro. Let's just go for it. So what we do is wait a second. Find mean. Okay, we have to find mean now. So what you know is wait a second, I have to change markers, I guess. I'll change markers for real, bro. Wait a second, for real, bro. For wait a second. Wait a second. I need my marker, bro. I don't know where I've lost it, but I've lost my marker, bro. That's really bad, bro. Let's go, bro. This is really crazy. So yeah, what I do is e of x equal to where's the so e of x is zero minus infinity to infinity, okay? Like all the number set that you can expect, okay? Log because mean is common for everything. So e raised x f of x dx raw bro. Wait a second, maybe not x, bro. Like wait a second for real. I guess it is yeah, I guess it is x f of x, right? Like, let's see. What we have here is e of x in discrete variable was uh summation pi xi. Okay. So what happens here is it is saying just in integration form, and I told you p here becomes f of x. Okay, and x becomes here small x. Okay, that's how things works here. So that's the difference between this discrete and continuous variable. Okay, so we did this, and obviously mean is like for overall range, it is applicable. It is same. So we take for all ranges. Like every till infinity. Okay, so let's just try for it. Try for it. Let's go. So by the way, we found e of x before, I guess. Like we found integration f of x, I guess. Okay, we found integration f of x. Now we have to find integration x into f of x. Okay, now this is gonna be a trouble. This is gonna be a huge trouble. By the way, wait a second, I should double check because I want to confirm and I don't want to give you wrong formulas so that you get into trouble, right? So I have to double check this formula. Wait a second, because I'm slightly confused about this. Okay, so I have to double check so that I don't give you wrong formulae. So that's the thing, and I'm a human, I can make mistakes. So the thing is, we should just learn from mistakes and try to correct them as much as we can. Okay, that's how things work, right? That is what learning is. Yeah. Yeah, bro, let's go. This is correct. This is correct. This is crazy, bro. This crazy stuff, bro. Let's go, let's go, let's go, let's go. We did this, we did this. Yeah, this is correct. This is correct, bro. This is correct. Ha! Let's go. Also, I had to define some other functions too, like variance. I also have to show you, like, let's just revise the formulas. Where variance equal to e of x square minus e of x whole square. Okay, okay. Let's go. Let's go, bro. Let's go. Ooh. Okay, now what do we do here is, so there is a formula, by the way. Okay, because also we have to find e of x raised to 4. So for that we have a formula. Wait a second. Let's say e of x raised to n is there. Okay. So what it means is you have to put integration 0 to infinity, minus infinity to positive infinity, which is normally there, and you have to multiply x raised to n to f of x, and then put your dx. Okay, that's how we do it. Okay, that's how we do it. Let's go, bro. Let's go, yo, bro. Waha. So now what we do is, we have found this. Okay, so wait a second. We have found this. Find mean, variance, and so yeah. So what is your variance? You understood, right? We have to just do this integration x raised to square 0 to infinity stuff f of x, whatever that is, like kx square e raised to minus x, kx square e raised to minus x minus integration wait a second, this minus infinity, by the way, minus infinity to infinity whole square, by the way. I would do later square, I guess. X k x square e raised to x minus x and whole square. Okay, I have to do that thing. Now what happens is, so this is gonna elongate so much. This sum is gonna elongate so much, bro. But whatever. So if we find mean variance, then this p of a to b. Okay, so now what we are gonna do is p of a equal to x equal to b. So there's a formula, by the way. You just have to do what do you have to do. This is about p. So what did I say? P is f of x. So you have to obviously integrate f of x. That you are sure. But this time they have defined your range. It is between a and b. So your lower limit is a. I guess 1 minus a, but whatever. A b. Let's go. So this is your this stuff, whatever this is. Now of a continuous function. Yeah, this is continuous. Then MGF, a raw moment from A. Let's go. So raw moment from A is, so A is an arbitrary point. So yeah, that's how you have to treat it. Okay. So what would happen is integration. Uh, Wait a second. What should I put here? Maybe minus infinity to infinity or something. I put this. Then raw moment, which means wait a second. Yeah, what was it in raw moment for this? P summation pi into x minus x minus a whole raised to r. Right. 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 Alright, isn't it? Isn't it? Isn't it? So let's just do that. So P is f of x, I told ya. F of x. Then this is x minus a, raw. So you have to multiply x minus a whole raised to r. And here we go. Let's go. Let's go. Let's go. Yo. So this is the formula of that. Now also we have moment generating function. Let's do that, I guess. Moment generating function. By the way, I forgot to add the another one. So what happens here is f of x equal to 0 otherwise. So this is also there. So what do you have to do here is in everything like this was there, e of x equal to this, right? So what happens here is I would add this to the second one, which is actually uh, since this range is given. So yeah, what I would do is I would put 0 here, okay, and I would put the other. So now only 0 and negative is there. So negative infinity is the lower limit, so I would put that. Now what I would do is uh so I would put the other function which is 0 in the integration here, integration dx, okay. So now we are here, bro. Let's go, bro. Let's go. Yo, what's up? Yo, what's up? What is up, bro? So this is our function right now. So, by the way, this doesn't change anything though, because zero integration is 0. Because I will explain it later. But let's go for this stuff, okay? MGF. What was MGF in like discrete functions? It was summation pi e raised to t of x minus a raw. Isn't it? Yeah. So we have to do the same stuff here. So what you have to do is integration minus infinity to infinity f of x into e raised to t x minus a. Here we go. Let's go, bro. Let's go. Yeah, dx2. Yeah, this is it. This is it. So we have revised all the formulas. So I just related to the so moment generating function is like overall biggest function in this. So we just put e raised to thing here. Others are normal. La moment. Wait a second. Let me show you. So in moment generating function from a, what you can do is there are actually three stuff like what you can specify is like how many and from where central uh, origin or two, right? So in moment what you can specify is like uh, power of the function and point of the function. So that's why we just keep this input, okay. We put these input in this. So how to put this is okay. So this is x minus a would be there, a always constant. So yeah, constant, what do you do with x? We mostly do minus anyway. So and r is in raised to, simple stuff. So it stays same for discrete random variable too. So yeah, and integration x raised to n f of x dx2. So all that stuff is here. So yeah, so I guess we have revised all the formulas. Now I guess we should move on to integration part, but I guess I would cover that in shots. So see ya, bye. Like to subscribe. Thanks for watching. See ya, bye.